Hi everyone, welcome on our 8th Reactive Meetup for IT people. That's something like anniversary edition, at least in binary. I'm really excited that you made the decision and join us because we are going to do a deep dive into the topic of micro-frontends. Today, you can look forward to 2 dev talks, so no meta talking today, just 2 developers talking about micro-frontends architecture. The first dev talk will be done by Luca Mezzalira, and he will be talking about how to scale your projects with micro-frontend approach. And the second dev talk will be done by MANFRED Steyer, and it will be about the micro-frontends revolution with Webpack 5 module federation with Angular. So really looking forward to both of the topics as they seem really exciting. Just to introduce myself, my name is Andy, or Andrej Skok officially. I'm from Vacuumlabs, which is a company that stays behind the original ReactiveConf from 2015. Other than that, we focus on providing flexible and reliable software engineers to clients all over the world, from LA to Tokyo, and we help them build various fintech, blockchain projects or online marketplaces. Of course, before we start, there are some notes from organizers, and more specifically 2 of them. First is that we have a Slack channel on reactiveonlinemeetups.slack.com, which is quite active. There is a channel for each of the online meetups, so feel free to join. And in case you have any questions, there are speakers there, I am there, and also a lot of other people, so we can discuss various issues there, so feel free to join. And the second is that there will be a Q&A for each of the talks. We will get to all the questions which you write into the Q&A section on your Zoom windows after the talks. So feel free to ask. We will try to answer everything as good as possible. So again, welcome everyone, and let's proceed to the talks. Luca will be speaking first. Hi, Luca. How are you?
Hello. Very
Hi.
well. How are you?
Oh, also great. So we are really happy to have you here with us
Thanks for inviting me.
today evening, at least in Europe evening. So let's proceed with your talk. I'm really looking forward. Micro-frontends is something which is on my project, at least. It's being mentioned during the last half a year, maybe 1,000 times. I have heard some arguments for it, some against. Nobody knows how to do it properly and where to start. So really great and really looking forward. So please enlighten me. You can start sharing your screen, and
I will do my best.
The stage is yours.
Thank you very much.
Thank you.
Let me know if you can see that.
I can see. You can proceed.
Give me a sec.
Thank you.
Thank you. Okay, so welcome everyone, and thanks for spending some time with us tonight. I think it's great that there are so many people interested in the topic. So let's start with who am I? My name is Luca. I'm a vice president of architecture for a company called DAZN. It's a OTT platform. Think about Netflix, but for sport, live sports mainly. We're available in 9 countries and about to release our platform in 220. So it will be quite a lot of fun the next few months for me. I'm a Google developer expert on web technologies, and I'm running the London JavaScript community in UK. So what we are going to talk about, we're going to talk about how to scale our front-end application with micro-frontends. And basically, I would like to share with you the insight that I learned from the trenches in the past 3 years working for my organization. Usually, when you start any project, either a startup or a new project, the first thing that you try to do is validate the business idea. So you want to understand if your project, your idea would succeed, and you want to gain insights directly from your users, so your potential users. And therefore, you need to try to get hit the ground as soon as possible. There is one famous sentence that if your first attempt is not as ugly as you expect, it means that you are launching too late. And I fully agree with that. So usually on the technical part, what you're trying to do is simplifying as much as possible, because the first part is validating the business idea. And therefore, on the technical part, usually, not always, but usually you start picking a type of database. It could be SQL, NoSQL, whatever you prefer. You go ahead and you design a monolith APIs that with your favorite language, Node, C#, Java, whatever. And then you end up creating, I don't know, a single page application for the sake of this discussion. The interesting part of this is that, as you can imagine, starting to put together these, it would allow your team to focus mainly on the business logic and less on all the rest that could be either the CI/CD pipeline, because you define once, everything will be there. You may or may not have infrastructure as code, depends how you use your setup, on-prem, not on-prem, on the cloud native, it really depends. But on the front-end side, you tend to use server-side rendering or single-page application. It really depends what are your goals for that specific feature, for that specific project. And therefore, is a really important that you start very light, and then you start to, let's say, create more complexity when and if the project will start to have traction with your users. And let's assume that is exactly what is happening. So your project is getting traction. There are more and more users interested to use your maybe SaaS platform. And what happens usually is something like that. So you start, you have a clear way to scale your backend. So you start to say, okay, so perfect. So we start to have all our services that are up and running, and we want to scale them. We know exactly which API, which traffic we have for every single API. We know how to scale these APIs, and because of monitoring that obviously you put in place, right? And you start to basically kill the monolith on the backend, creating the first microservice, and having something in front of as entry point, like an API gateway or a backend for frontend, it doesn't matter at this stage, but something that would allow you to redirect and shape the traffic towards one microservice and the monolith till you are ready to have all the microservices available inside your infrastructure. The interesting bit of this approach is the fact that you start to iteratively create value for your users. So you start to have your existing monolith that is collaborating with the brand new microservice. A microservice has amazing characteristics because you have some teams that you can start to shape the structure of your organization around these microservices, maybe following some domain-driven design suggestion, and maybe following dividing your application in multiple domains. So I don't know, in the domain-driven design, usually you can have like core domain that is basically the reason why the application is up and running. And you have like the supporting domain that are supporting domain that are helping the core domain to succeed. And then you have generic domain. Like for instance, if you think about Netflix, an example of generic domain is the payment. It does not any let's say competitive advantage to Netflix, but is needed because otherwise you cannot subscribe. A supporting domain could be the search option in Netflix. If it's down and you don't notice that, it's fine. As long as you are capable to, let's say, browse the catalog and play some content, you're fine. And that is exactly the core domain of Netflix. So they have created a platform that allows you in any device to watch some content at any given point of the day. Because everything is a video on demand, and you can watch when you want instead of go on a linear channel when it's needed. But what happens on the front end? Front end is usually, in my experience, we try to keep to extend the amount of developers working on the same code base, but we try to maintain exactly the same code base that we started in the first iteration. That is not, let's say, usually wrong, but it could lead to some bad practices. One, for instance, that I can come up with is maybe we started this the design on the left of this slide, I don't know, 2 years ago. And when we started to do that, what happens is that we have some assumptions and we take some best practices at the time. But in 2 years, the technology changes completely. And also our assumption, the business is changing completely. We are talking about two dynamic entities that are evolving every day. And therefore, maintaining the same code base, it may or may not be a good call. And therefore, you need to figure out if there are better ways to do that. One way is, for instance, rewriting completely from scratch the application. But if you think about that, you start to have quite a few challenges in front of you. How do you sell to your business that you need, I don't know, 8 months for rewriting everything? You cannot add any feature because all the developers are working on that. Those are the kind of challenges that we faced for several years. And obviously, you need to find the right trade-off between enhancing the architecture and the technology and delivering value for your users and your organization, because that is always a trade-off. So starting from this point, and that was exactly the point where I was a few years ago, I start to ask myself, can I see a way that I can apply the microservices principles to the front end? Why that? Because microservices is a well-known architecture pattern that is leveraging certain principles like the independent deployment, independent technology agnosticism around the microservices, the fact that every team is independent, you structure the team in a certain way, so you are scaling your organization as well your architecture organically. But on the front end, we didn't have many solutions up to now. So 3 years ago, obviously, there wasn't the name Micro-frontend, but what I came up with, it was something like that. That basically, I was starting to slice my application and my platform in multiple, let's say, vertical slice, how I call them, that would allow me to, let's say, create a unique domain end-to-end from front-end, back-end, and infrastructure, and create the possibility to my teams to have freedom inside this domain. And that is basically how usually I think about micro-frontends. So let's try to find a description on how we can define micro-frontends. So obviously at the time, there weren't many literature around micro-frontends, and we need to find a way to define them. In my opinion, if we think about characteristics of micro-frontends, we can say that micro-frontend is a representation of a business subdomain that is coming from domain-driven design. And if you're thinking, oh, but domain-driven design is applicable on backend, yes, but part of it can be applicable on software engineering in general. Therefore, I think is, let's say, limitative if we think just of domain-driven design on one area of an application. They allow independent implementation, so the possibility to independently deploy specific artifacts with same or different technology. And they should avoid sharing logic, because if we want to maintain independence, usually the sharing part has to be, let's say, well thought. You can do that on micro-frontends as well, but you need to properly thought pros and cons of that choice. And finally, they're owned by a single team. Now, why I put emphasis on the ownership part? One thing that I often see failing in projects is when there is no clarity on ownership. Who is owning what? And it's not for a blaming culture at all. It's just because if you have someone responsible, then that person or that team can take over and take the decisions. Because when you have too many heads in a room that are trying to shape, let's say, the future or of a specific functionality, you risk that you don't find the quorum and the agreement across all the people. So having someone that is responsible for that can be the way how you can speed up the discussion. That doesn't mean that you need to have a dictatorship. This is not what I'm saying. Is you need to have someone that is responsible for the life cycle of a specific artifacts. So creation and also dismissal of that, because sometimes you need to dismiss certain part of your application, and you need to have someone that think how to do that end to end. So usually what I discover with micro-frontends is that you need to take certain decisions. And I came up with this mental model solution that I call the micro-frontends decisions framework, that allows you to go through 4 stages and identify which architecture of micro-frontends you should pick for your specific project. And that is, in my opinion, very helpful, because often I see people that are comparing micro-frontends or associating micro-frontends to components, or start to say, oh, but I can use micro-frontends for me is just taking multiple components, put together, stitching together in a view, and that's it. It's slightly more complicated than that. And let's see what I'm talking about. So the first stage of the micro-frontends decision framework is identify your micro-frontends. And how you identify the micro-frontends is basically shaping the way how you structure your teams, how your communication flow works inside your teams, as well as how you're going to define your technology choices. And that's very, very important, because that the first decision is basically already shaping quite a few and filtering out quite a few options for you. First one is identifying micro-frontend. So as you can see in this one, you can have what they call the horizontal split, so multiple micro-frontends in the same view, or you can have, let's say, micro-frontends that are a representation of a single page application, if you want, or a vertical slice of the application, because they represent a business domain. But the thing that characterizes a micro-frontend over a component is, with micro-frontends, you are trying to solve a business problem. You're not trying to solve a technical problem. And that's very, very important, because when you start to get your head around that, you will start to understand the difference between micro-frontends and components. So you can pick the vertical one, so assigning multiple teams that are composing a specific view. And then you can have like instead one team that is responsible for a vertical. That could be either a single page or a single page application. So both kind. The second and third decision that you need to do is how you want to compose your micro-frontend. So you pick, you want horizontal or vertical, and then you say you need to understand how you want to compose them. You want to compose them at client side. You want to compose them at CDN level, or you want to compose at the origin side, so server side. And the other thing is how you route your micro-frontend. So where is the logic that says, okay, now I'm moving from this view to another view. So let's start with the first one, composition on client side. So the one on the left of this slide. So you can see that you can have client-side composition. So you can have multiple micro-frontends that are living on origin. Could be either an application server that is serving static files, or in the most simple way, it could be done on a S3 bucket or anything that allows you to store some static file. And then maybe you have a CDN in front of it in order to create some, let's say, replication across the different point of presence that CDN network can have. And just have an orchestrator on the front end that is just retrieving for and composing your micro-frontends. Either they are a vertical split or horizontal split. In that case, where you route, you usually route at the client side level or the origin or the origin level. It really depends how you want to compose them. Second way is edge side composition. There is edge side include, that is a markup language. It's not, let's say, probably super known like HTML, but it's similar to it as a markup language that you can leverage at the CDN level, or in specific, let's say, reverse proxy like Varnish. You can do that as well. The interesting part is that you don't have to scale your origin. You have like static files that are picked up by origin level, and you describe your composition of page. So in this case, for instance, you normally have more an horizontal split. So you have multiple components, and you describe micro-frontends, and you describe how those micro-frontends are stitched together in the view through this markup language. What the CDN does is, every time that you request a page, is reading is parsing the markup language and substituting every markup language with a specific micro-frontends, with a concrete implementation of a micro-frontends. That is a way. And the routing on edge side composition is happening on the edge. The final way, that probably is the one that you have the most control way, and it's when you do composition and routing at origin level. That's a very, very interesting one, because basically you can do either horizontal or vertical split, but usually when you do server-side composition, you do a horizontal split. So you have multiple pieces that are stitched together at runtime, or are let's say, stitched together and then compose and store at the CDN level. So there are different, let's say, flavor of this implementation. You can see, for instance, open components is one flavor that is composing everything, and you have this runtime agent that are composing and showing everything on the CDN because they're very static, and is used by a Skyscanner or OpenTable. But there are other implementations that instead are stitching everything together at runtime. They're using the CDN with lower TTL, and therefore they are just absorbing the high traffic at the CDN level, but there are some codes that are happening and hitting origin at runtime. And at that stage, what's happening at the application server is composing different micro-frontends together, and they compose the final view, and they serve everything to the clients. And there is no right or wrong here. There are, let's say, different solution for different challenges and contexts that you operate. So don't be fooled and think, oh, this is the right one, this is the wrong one. The context define what is the best trade-off, because there isn't perfect option either in architecture for picking up the best trade-off of your architecture. The last thing that you need to bear in mind in the Micro-frontends decisions framework is how you are going to communicate. So usually you have, when you have multiple micro-frontends in the same view, you need to figure out a way, because sooner rather than later you need to do that, how the micro-frontends are communicating in the same view. Could be that, for instance, you use an event emitter. So you inject an event emitter from the host application that is containing everything, and you inject this event emitter instance in every single micro-frontend so they can communicate through events. Or either you can use what they call the custom events, these available standard JavaScript APIs that you can use for communicating between components. In that case, you don't inject anything. You rely on the fact that there is, you listen for any event that is happening in the window object, and you do window.addEventListener to a custom event. And the micro-frontend basically that is interested in a specific event will call the callback that is associated to that specific event inside your logic. This is like when you have multiple micro-frontends in the same view. When you don't have that situation, or when you want to communicate across views, you can use either the web storage, like session storage or local storage, or you can use query strings or even a backend API. A classic example that you can find is, for instance, you have like an e-commerce with all the catalog and with all the products. The user click a specific element, and you pass in query string the specific ID of the element that was clicked. From there, the new micro-frontend is retrieving from query string the ID and requesting to the backend all the information that is needed in order to populate the micro-frontend. So those are different ways how you can communicate in different situations. But again, when you nail those 4 decisions, you basically filter out all the complexity and all the other things, and how you are doing, for instance, your designs, how you design your design system, how you define your design system, how you define the communication across teams, how you define the different aspects of building an application are, let's say, more clear in your mind and also your organization, because those 4 key decisions will drive a lot. Will just create a nice canvas that will allow you to go and iterate through in order to fill up all the other technical decision and organizational decision that you need to make. There are many companies that are using micro-frontends. Currently, I just want to highlight a few approaches that you can have. Like, for instance, in DAZN, that is the company I'm working for, we are using a custom implementation. We are going to see in a moment this. OpenTable is using open component, is open source. So if you look for open component, you can find a lot there. Zalando before was using Mosaic and especially Taylor.js, that was an open source framework that they released. They're not using that anymore. Currently in their website, they are discussing about this interface framework that is the evolution of Mosaic 9 and Taylor.js. Is not open source in this case. They made certain different decision. I think Taylor.js is very open and is not working with a specific framework and work with any UI framework. In interface framework, instead they took an opinionated way using GraphQL and React components and React, sorry, for creating their micro-frontends. IKEA, for their catalog, they're using edge-side include, that is the CDN approach, and they are using that in combination with another technique that is called client-side include, where there is a transclusion between elements. So there is a placeholder that is substitute with the real micro-frontends. That is another interesting approach. And finally, Spotify on the desktop application only is using iframes. And that is a composition of multiple iframes inside the same view. They moved away of using iframes on web for clear problems that could happen when you have iframes. So if you have like 5 different, if you have the same framework or different, let's say, libraries, you cannot share them across iframes, so you need to reload them. So for web, it wasn't for a B2C, let's say, application the wisest choice ever. For desktop, makes sense because everything is inside your package. Also for B2B application, there is a SAP that is using iframes in their micro-frontends framework called Luigi framework. And there they are using that because in reality, iframes are solving quite a few problems like memory issues and other things. And if you use wisely in a B2B environment where you can control, for instance, think about SAP, they can control the browser that are used by the user. They can control how many users are using that specific B2B application. So it's a very, let's say, self-contained and isolated use case where iframes may work without too many burden. Obviously, if they need to use, if their, let's say, goal was having a full SEO and a B2C application, probably I would say it's not the wisest choice ever, but in certain occasion may make sense. So what we have done in the zone. The zone, if you don't know what it is a multi-device experience, is an OTT platform. Think about Netflix, but for sports. We are currently targeting on the front end roughly 40 different devices between set-top boxes, console, web, mobile, and smart TVs. So quite a few. On mobile, we're using native languages, so Kotlin for Android and Swift for iOS. Same for Apple TV. But for all the other devices, we're using HTML5 and JavaScript. So there, our micro-frontends application helped a lot, especially for TVs. When you have like a very low power device that usually is pretty old, because the penetration of TVs, usually you deal with devices that are, I don't know, from 4, 5 years old, if not 10 years old. So that kind of devices. Power-wise, they're not, let's say, a MacBook Pro with the quad cores, so the memory footprint is very small. So using a wise architectural choices would help to have better performances. So what we have done in the zone, I remember when I joined, it was 5 years ago. We started the project 1 year after I joined the zone. And what happened is I was the second person in the tech department. And the CTO one day came to me and said, listen, Luca, bear in mind, we want to grow this company very quickly with hundreds of developers. And I was the second person. So imagine that the difficulties on thinking how I can create something that would allow us to scale not only on the technical side, but also on the communication flow. And it was right. So we moved from roughly 50 people in 2015 to over 3,000 in 2020. So in 5 years, we had this blitz scaling growth. Obviously, not all of them are engineers. We have roughly 400 people in the engineer department, but still quite a lot, moving from this small amount to all these people, internal developers. So what I did in order to start this project, to kick off this project, I started with data. So first thing, I started to understand really how our users were using our application. What I discovered is that there were some interesting patterns. I just check usually Google Analytics in that case, what we are using for this kind of data, and engage with the product team in order to understand the user flows. And looking at the data especially, I was quite surprised. So the first characteristic I discovered that the user, we had like millions of users per day that hit the landing page, but part of them, they didn't move forward. So it means that on landing page, they load like the entire single page application, with the SDK for payment, the credit card, everything. And then after loading the landing page, they just leave the website. Not a proper nice experience if you think about the single page application. Then we have another, let's say 70% that move forward and they go to the authentication phase. But also there was a drop. And what I noticed is that there was a pattern in our case where the user was, let's say, click on the sign up process. And in the sign up process, they started to understand that the different payment methods, they didn't find the payment method that they wanted. And they basically create a partial user. So they just have a partial sign up, but they didn't subscribe to the event. And then they dropped the application. So up to now, we're already seeing 2 use cases. User that wants to go on landing page only to understand what the product is and leave it. Users that are interested on the project and they start to engage with the sign up, but they didn't find what they were looking for on payment methods and they leave. And finally, we have the third type of user that finalize the sign up funnel. They go on the discovery, and so they subscribe and they go to the catalog page. And what we notice is when you are in the catalog page, not many users left that area. So they remain inside the catalog for watching content. And that was across all the devices. Very, very interesting pattern. So basically what we discover is that when you are an existing user and you sign in another device, you remain in the authenticated area for 99% of the time. You don't leave that. And that means before with the single page application, we were downloading all the SDK and all the other burden that we're not using really on the authentication, on the authenticated area. So that was very interesting, and discovering the pattern of how our users were using was very, very interesting. Then I was able to map those domains and micro-frontends towards our backend, but that is another story that we're not going to cover today. But it's a very interesting approach, understanding how to let's say describe your context and your domains following user let's say user flows. Then we have a customer support and my account. So every single box that you see here is a micro-frontend for us. And we needed something to orchestrate everything. So how we can migrate from landing page to authentication? What we created is like a tiny layer called Bootstrap that is available for the entire user session on any device that we use in this architecture. So basically you type DAZN.com, you load the Bootstrap, and then the Bootstrap does certain magic that we are going to discover in the next few slides, and then is loading a specific micro-frontend based on some logic that is baked inside the Bootstrap. Obviously, there is logic that is coming also from the backend, but in this case, the Bootstrap has some logic that allows us to route across multiple micro-frontends. So let's define what a micro-frontend is for us. So a micro-frontend represents a business subdomain, as I described before in the description of micro-frontend. It's technology and framework agnostic. What it means is we can use any technology that we want for every micro-frontend. And I can tell you that it doesn't mean that we need to have multiple framework in the same application. In fact, in our case, funny enough, I provided this possibility to go with any technology. Everything picked the same combination. So React and MobX in our case. But the funny part is we were able to update certain part of the application with new, let's say, framework versions faster than others. And no one has to coordinate all the effort to make sure that all the features were up and running in all the different devices. Because as you can imagine, when you have just web is one thing, but the effort of having these on multiple devices could be quite big. And then we have micro-frontends that are autonomous, so we can deploy independently. Every micro-frontend is owned by a team and can share components inside the micro-frontend itself. They have their own independent built-in system, so the company provides some tools for doing that, but what is written inside the building pipeline is done by the developers that are owning a micro-frontend. We always load, we have a relation between Bootstrap and micro-frontend is 1-to-1. So one micro-frontend per time is loaded, and we don't have multiple micro-frontends. So that fade out the complexity of CSS clashing or dependency clashing and other stuff. So it's everything fade out. And the ownership is one team, one micro-frontend. Technically speaking, our micro-frontend has an entry point, an HTML page, and we have then a business logic JavaScript file, a vendor JavaScript file, and some CSS. Why an HTML page? Because what we can do in our system is we can decide at compile time if we want to server-side render part of the skeleton of the UI, and therefore being able to display the content immediately to the user. Meanwhile, we are loading the JavaScript file and CSS. That is a nice feature because, especially on TV, it provides a very snappy experience for the users because we can immediately start to, let's say, render something meanwhile we are loading a specific micro-frontend. Bootstrap is responsible for 4 key actions. So the application startup that is common for all the micro-frontends, so understanding which country the user is, which device, the configuration for that specific device and country, and so on. Input out of operation for the device. So basically, every TV may or may not have local storage available, and therefore we can, let's say, have different ways to interact with the input out of operation. So in the Bootstrap, we have this logic that is wrapped per device, but the micro-frontends are completely unaware. So the Bootstrap what exposes an API for every micro-frontend to write and retrieve information from the persistent layer that we have in every device. The Bootstrap is responsible also for route between micro-frontends. So decide that on a specific route, it will load one micro-frontend or another one. And also sharing configuration. Big classic, when someone is not authenticated and is going to the sign-in micro-frontend, can authenticate. The micro-frontend is responsible for consuming the API for retrieving a JWT token, and then pass this, store this JWT token inside the local storage through the Bootstrap, and Bootstrap will load at that stage a new micro-frontend. That is the authenticating micro-frontend. It's retrieving the new micro-frontend is retrieving immediately the JWT token and make sure that the JWT token is still valid, but always through the Bootstrap. So the Bootstrap is facilitating this communication. The Bootstrap is nothing more than a vanilla JavaScript implementation, very light, and basically is embedded inside the initial index HTML that is downloaded when you type DAZN.com or you open the application. How we mount a micro-frontend. So the logic is, in our case, we said we have an HTML entry point, and HTML is basically XML with a specific schema. So what we do is the most basic thing. We have a nice HTML that can be parsed. So the Bootstrap knows the URL of that HTML. It parses the HTML, and it starts to append inside itself the different markup language. So you start to add, if there are any server-side rendered nodes, it's going to add in the body. If there are CSS and script are going to append inside the body or the head, depends where they are inside the entry point of the HTML. But that is a very standard way, not opinionated at all, that allows us to use the best breed possible on the JavaScript community. It doesn't force us to build every time there is a new framework that is coming out or integrating with a third-party company. We can do that in a very simple way because everything is a standard, everything is vanilla. We don't do magic here. It's literally parsing an HTML or XML file and appending the nodes inside the Bootstrap. And when we want to unload, we just remove all the nodes. We call an endpoint, some callbacks that are available, as you can see here. We create an object called the zone object, and inside there you have lifecycle events that are called on every micro-frontend. So when the Bootstrap notices that everything is loaded, it's notifying that to the micro-frontend, and if it's needed to do something, the micro-frontend will act upon that. And the same way, when the Bootstrap is saying, oh, now it's time that you unload the micro-frontends, what is happening is communicating that to the micro-frontend. The micro-frontend is removing all the pointer to listener and everything, and then we unload the micro-frontend, we load the new one. That is how we are dealing with micro-frontends. Currently, we have 6 micro-frontends. We are heading towards 7 and 8 very soon. But again, it's a limited amount of micro-frontends that we have, and we can map them and scale our teams horizontally in this way. We have also components, because there are certain things that are fairly complex in our application. Consider that we have an OTT platform. One of the most complex things we have is the video player. The video player, we have a dedicated team, roughly 10 people that are taking care about all the video player for all the devices. And trust me when I say it's not easy, like I take one open source video player, stick in a page, done. It's way more complex because dealing with live content is a completely different beast than video on demand. So the optimization, the heuristics behind the player has to change. And we have this team that is looking after these things. What the video player, for instance, is a component that has, let's say, is stored inside an NPM private repository and is used in currently 2 micro-frontends. It's like normal life cycle of a components library. So the Micro-frontend is loading the latest version. Up to now, we always work with components that are loaded at compile time, so development time. And now we are looking at loading at the runtime with some twist on what you can load. For instance, what we are going to allow is in 𝗬𝗪's spec, we are allowing minor and bug fixing to be loaded at runtime and published without any problem. But when there is a major fix, we need to change the code on the Micro-frontend in order to bump up the version. That is needed because for us, that specific component is a key component, and it has to be battle tested. So we cannot really afford to have an issue on the video player. So that is a trick that we put together in order to manage that. Every component is owned by a specific team and can be shared across Micro-frontends. Now, one of the questions usually I have at this point is, okay, how do you handle the design system with if you have just one component at the moment? So the design system is composed usually by design tokens and components. And what we do is we stop at the design tokens level. So we define the font size and the colors and font type, family, and so on and so forth. All these things coming common across the application, and then every Micro-frontend is implementing their own. We are currently looking how we can extend this concept to components, but the problem we have is because we don't have only, let's say, one unique, we don't have only web, but we have also TVs. It's limited the amount of things that we can pick. So we tried web components, for instance, and are not supported also with polyfills on many TV devices. And therefore, we need to look on building custom libraries per framework. So in this case, mainly React. But that is something that we are currently iterating, trying to understand and play this game on understanding what is feasible, what can go wrong, how we can design a decent governance around that. But yes, the application is has some components that are duplicated. And yes, not many, to be honest, if you look at our interface. And yes, the application has some consistency up to a certain level. So those are the things that we are currently doing. There is another interesting thing that we introduced with this approach. We introduced canary releases on frontend. And basically, we have currently a Lambda at the edge. It's a computation layer made with Lambda, serverless Lambda, on AWS layer that are running on the closest origin from a point of presence of a CDN point of presence. So CloudFront and the closest point of presence will call a specific origin, a closest origin from that point of presence, and will run some code on that. And that code basically is a Node.js application that that is basically shaping the traffic towards a new version of a Micro-frontend. And we use the same way for killing the monolith. So we had for a certain period of time the single page application that was running alongside the Micro-frontends, and we start to iteratively adding new functionalities and everything, and we're shaping the traffic based on the country, the browser, and the traffic that we want to have. And everything was shaped at the infrastructure layer. So for the Micro-frontends, the development wasn't custom for that specific feature. It was normal development, slowly but steady. We were basically killing the Micro-frontend using the strangle pattern that is very well known in microservices, but applied on the frontend. And at the bottom of this slide, you can find a link that I describe even better the process around that. Conscious of the time, try to wrap up. Interesting enough, one of the things that we achieved with that is one day I arrived in the office and I have like 5 new teams that started to work on the front end. We started to onboard them. It was very quick because we explained the architecture, but we provide them the freedom to really leverage their best, let's say, technology decisions and what they know better. And therefore, after 2 weeks, roughly 1 week, more or less, they started to create value. So they started to ship incremental value to our Micro-frontends. And that for me was a big win because it means that we were able to really create something that wasn't too opinionated and very standard, allow everyone to start to chip in and contribute. Another interesting thing is we scale like from 2 people, as I described before, to over 400 distributed in 4 dev centers working on the same platform. Obviously, we are talking here about front and back end developers as well as QAs and Scrum Master, or whatever is a great achievement, because we move the front and the back end of our application to microservices and micro-frontends, allowing, let's say, and shaping also the communication flows based on the architecture. That is a really, really interesting thing. If you, I know that I stress a lot during this presentation, the communication flow with architecture, because I truly believe that you cannot design an architecture without thinking how the organizational impact of your architecture. So you really need, when you design an architecture, to think about the communication flows across all the teams, because you can create the best application that maybe fit the context, but maybe it cannot be implemented due to some constraints that you have inside the organization. So please think very wisely about that. Finally, in the last 2 years, we didn't have any S1 incident in the platform. I'm very proud of that, because our, let's say, platform, it was released 4 years ago, and since then we always doubled every year the amount of users. And obviously, when you move from 10,000 to 20,000 is one thing, but when you move from 1 million to 2 million, it's a completely different beast. Obviously, we have way more users than that, and as you can imagine, being able to de-risk and have atomic deployment and shaping the traffic on redirecting traffic towards a part of our user base was really, really helpful for this development. That said, I'm open to a Q&A, and thank you very much for your time. If I won't be able to answer all your questions, you can find me on the Slack channel that I think by now will be in the chat, as well as you can contact me directly, and you can follow me on my blog, where there are quite a few posts around micro-frontends. Thank you very much.
Thank you, Luca. Thank you very much for your talk. It was very inspiring. We have a lot of questions here. Before the second talk, so I will not forget. I suggest for all the viewers to have a drinking game every time the word micro-frontends is mentioned, or for someone who would not be able to endure this, I suggest to have a push-up every time someone says micro-frontends. That would be a really great exercise. So the questions, there is a lot of them, and I started to put likes on some of them, so it's a little bit biased as I look at it, but I will try to go from most liked to the least liked. So first of all, hi Luca, how do you share libraries between micro-frontends like React, Angular, or Vue? So mostly the base framework, rendering framework.
Mm-hmm. Okay, so when they are shared component, usually you tend to use web components if you can. That could be a good practice. If it's a design system, I was talking with another company, pretty large, probably larger than us, where they were telling me that currently for the design system are creating one library per framework. My experience, although, is telling me that, for instance, you tend to not have a platform or an application that is composed by multiple frameworks. So when despite that you can do that with micro-frontends, it doesn't mean that you have to do that. So there are certain situations where you can use multiple frameworks successfully, and usually is through when you have a legacy application that maybe is written with an old version of React or whatever, and you want to migrate to a new one or a completely different framework. That is one thing that you can use different frameworks. But in general, the best practice that you have in a single page application should be applicable on micro-frontends as well. In the next talk, Manfred will tell you another technique, and I don't want to spoil that, for sharing code across multiple micro-frontends. But I leave to Manfred this answering the second part of this question.
Yeah, sure. Thanks.
You're welcome.
Obviously, we will get back to this question if it will be left unanswered by the next talk. Chris is asking, what is the advantage with micro-frontends over root-based code splitting? I would maybe use. Yeah. Go on.
Yeah, that's a good question. I think code splitting is just one way to manage that, but you have a centralized way usually that you describe how you want to split your code and everything. Micro-frontends, if leveraged properly, you can really create, let's say, custom domain that can go at a different speed. For instance, one thing that I noticed is we don't have to coordinate when a specific micro-frontend is going live or there is a new version on anything. It's literally, it cannot break anything. It's self-contained and you can deploy completely independently without any problem. You don't have to coordinate with other teams. You can do everything that is you want. And also the other nice thing is, for instance, one example, we wanted to try quickly in certain landing pages that is the smallest, let's say, micro-frontend that we have, to when React hooks came up and we wanted to try meanwhile they were in beta. So we tried to do that and we tried in production straight away. No one was involved on that. The interesting bit is the team responsible for that part tried with one specific landing page. They tried, they shape the traffic, they gather some information, and they feed back through the community practice our other teams. And that is a nice way that you can also innovate using micro-frontends. And usually the fact that you can structure everything in a way that there isn't a centralized way to manage everything allows you to really run independently. Obviously, it's impossible to not have any coordination at all between micro-frontends, but the goal is minimizing this communication flow in order to have a very fast communication across teams, especially when they are distributed.
Just to keep on with the conversation, I will be some devil's advocate here. That a lot of independence, usually it can backfire, and it can mean that the teams will desync quite hard. For example, they will include the different versions of the same library. So you will end up, the user on their journey through the application will load the same library 5 times with in 5 different versions. With a mobile internet, for example, like that can put a lot of pressure on data usage. Also the parsing of the JavaScript is non-trivial on mobile devices, low-power devices, for example, on certain markets. So how are you? How do you manage this duplication? Because from my point of view, this puts a lot of pressure on the communication of the teams. The keeping it independent seems like, okay, yes, this is something which I want to have, but from my point of view of someone who is not using micro-frontends, it seems like something which can be hardly achieved.
I don't think it's hardly to achieve, because if you think about that, we were using so there are several ways that you can enhance this part. So it depends which micro-frontends implementation you would go for. So as I explained in my talk, you can have like an horizontal split. So in that case, you can have hundreds of you can end up having hundreds of micro-frontend. In our version that you have like vertical split, it's easy because we have like 6-7 micro-frontends. So it's very easy to manage that kind of complexity. Although there is one thing that you need to bear in mind. There are ways that frameworks are allowing you to share, let's say, libraries without any problem. For instance, MANFRED, again, we'll speak about one of the techniques probably around that, but another one is single SPA that allows you to share the library across all the different micro-frontends. And this is totally doable. If you think about that, we do on single page application without too many problems. That's why we have tech leaders and let's say architects that are helping on this. But furthermore, I would say there are interesting options that you can run in your CI. For instance, there is this concept on evolutionary architecture around the fitness functions, where you can run some architectural principles automatically inside your CI. So you can inspect your package JSON, and when you start to see that you have multiple libraries that are, for instance, developed with not the right version that you expect, or different version, or multiple libraries loaded inside the package, you can prevent that the artifact is built. So you don't have only, let's say, human beings, let's say, for enforcing certain rules. You can do that also at the CI level.
Yeah, so pretty much enforce everything you want to avoid, enforce it in some CI or some static analysis.
You can do that.
Or
you can do also with coordination. It really depends the way how to do that. Usually, we use a combination, for instance, when it's needed. In our case, for instance, we make a conscious decision where we don't share the UI framework. So because studying our user flows, we noticed that let's say it's 30Ks more every time across all different bump when you change micro-frontend. And when you are in, you don't move from there. So it really affects a really tiny proportion of our users. The other interesting bit is our use case is very specific. On mobile browser, for instance, we don't allow users to watch any content, not because it's not doable, but because the experience and the quality that you can have with native technologies on mobile is by far greater than what you can have on inside the browser. So therefore, for us, we are trying to redirect our users when they're authenticated to the application and not having a mobile experience. So also that case is helping us on achieving what we, or taking this decision. And again, context often drives those kind of decisions. It's not, oh, but DAZN is doing that way, but what a stupid decision. You need to understand why we are taking that decision, and there are strong reasons looking at data that are allowing us to do this. But in other situations, probably you cannot do that, and I agree with you. You need to enforce that. Could be either at the framework level or it could be at the CI level.
Understood. Thank you very much. So let's go for the next question, which is that I always hear a lot of pushback on iframes, mostly around security. Is that still the case?
Yes, unfortunately, they didn't evolve too much. There are some, currently there is a proposal around what they call the realms at the TC39 that potentially could replace that. They are creating a sort of sandbox like an iframe, but without all the burden and issues that the iframes are bringing together. Iframes, I think, in certain occasion may work. If you think about, for instance, the example that I brought up, like Spotify on desktop, that case, you're loading from your hard drive. So it doesn't provide too much burden, but it provides a lot of isolation around the system. So and also is supplemented with native code when you need to go native, because obviously all the UI is a web application, but everything that is low level is done at Objective-C or Swift level. So they can have the best of both worlds. So in that case, I would say that is a good way to approach that part.
Thank you. Next question here. You mentioned why micro-frontend per one team, and it sounds like the micro-frontends are quite big. So I'm wondering, how many teams do you have at DAZN, and how many members approximately each team has?
Okay. Yes. So in the zone, what we have is, let me count. So we have 1, 2. So we have 6, roughly 10, 12 front-end teams that are working on this architecture for TVs, all the TVs plus web. Plus we have then, every team is composed by 4 to 6 developers, more 4 than 6. And then you have QAs, Scrum Master embedded. And we have quite a few distributed across different dev centers. Every dev center has its own subdomain, business subdomain that is taking over. So all the acquisition attention, for instance, is in Amsterdam, and front and the back end. So they can collaborate in the same location. So when we structure the architecture, we restructure the organization in order to achieve a very frictionless communication flow.
Hopefully answered, pretty clear. Next question. I'm sorry, maybe I didn't notice, but are there any cons to micro-frontends?
The first one that I would say is complexity that are brought at several levels: organizational level, CI level, and also it could be performance level if you don't pay attention. So there is an intrinsic, let's say, effort and investment that you need to do when you do micro-frontends. Because as for microservices, you simplify the cognitive load for every single team that is loaded, that has just in their head a tiny bit of the business logic. But at the same time, you're adding complexity on orchestrating all the infrastructure across multiple teams, and you can end up, there are a lot of horror stories around there on microservices on the big ball of mud. And the same thing could happen on micro-frontends if you don't invest constantly, not only on the let's say features, but also on the maintenance and the developer experience, the CI, and so on and so forth, for creating this. Also, the communication logic, the communication flow are important. But also the CI, the developer experience, how you can create a smooth experience for creating new micro-frontends, especially when you go in a horizontal split. Those kind of things. You cannot really tackle micro-frontends thinking, oh, I do the first investment, I prepare all the CI, and I will not touch again because no one noticed, no one knows how to do that. That's something that I experienced in the past in a single page application. With micro-frontends, you need to constantly invest on that. Therefore, that for me is if your company is not ready to invest on that and give space to the developers to nail and improve their let's say tools and CI, don't even start with that, because it's to a certain extent, if you want, expensive, but it's paying back, because you are risking a lot the deployment and the development of your code.
Thanks a lot. And I will just ask the one last question, but there are 6 more. Maybe someone, we can wait till after the next talk, whether some of the questions will be unanswered, or if you can, you can stay and type the answers for some of the questions. They may be maybe trivial, some of them, and the rest of the folks, I would kindly ask you to continue in the Slack channel. Like, this can be a pretty interesting discussion also between the attendees, so feel free to continue on Slack. Absolutely. So, and the last question here is, hi Luca, how DAZN Bootstrap layer handles unloading of the micro-frontend and cleaning up the DOM from exact nodes for micro-frontend being unloaded?
Yeah, we don't do magic there. We just do a very simple and if you want, dumb way to do that. We just label them, and we just have every DOM element that we say, oh, you need to append this, you need to, and avoid that. Because sometimes, as you can imagine, because you have as entry point in the developer experience an HTML page, it's easy to test, because it's like creating a single page application. And that for me was another goal that I wanted to have. I don't want to change the way how a front-end developer is used to work. So in this case, what you can do is also faking the bootstrap and injecting certain specific configuration when you are testing. And we created this layer that this tool that allows us to do that. But in general, what we do is literally we have all the labels around the tags, and we just add and remove what is tagged basically inside the DOM. And the other interesting bit is we are asking, that's why we have the lifecycle methods that I described before in the Bootstrap. We do a callback on that, and we're notifying the micro-frontend is about to be unloaded, because he has to do his part. He has to remove certain things like listeners or elements inside the DOM in order to make sure that everything is clean and is not, let's say, using too many resources. Because especially on web, you notice less that problem. But on TV could be very problematic, because when you have like a limited amount of resources, every byte counts. And that's why we had to do in this way.
Yep, thanks a lot.
You're welcome.
Thanks a lot. So just to wrap up, thank you, Luca, for your time, for staying for the QA. Really a lot of questions there from people. So this would never stop. So I have to stop it now.
Yeah, of course.
I will jump to your book sometimes in the future, for sure. As I see that there is one, it can be
it's not finished yet. I'm writing right now. I'm almost 70% complete. I'm finalizing this week another chapter. So I hopefully by the end of the year is ready, and then will be available on O'Reilly website and Amazon next year.
Yeah, so we are really looking forward.
Thank you very much
to that. So thanks again, and we will continue with Manfred. Manfred, are you here? Hello.
Yeah, hi.
Hi, very nice background. So I see you are at
you
home.
know, I talk a lot about enterprise software, so here we have the enterprise.
Yeah, enterprise applications, they are my favorite. So yeah, we are really looking forward. So already Luca forwarded some questions to you. So there is some extra pressure for you answering it because he will be long gone, of course. So really looking forward to your talk, and stage is yours. Share your screen and go for it.
Okay, cool. So first of all, thanks for having me. It's a pleasure to talk here about one of my current favorite topics, namely the micro-frontend revolution, as I call it, with module federation. And I'm doing this with an example written in Angular, but anyway, it would also work with other single page application frameworks like Vue, React, and so on. And I want to start with a question. Do you remember this woman? Perhaps you remember her. She was one of the heroes of my childhood. I give you a tiny hint. It is, yeah, she was from Knight Rider. She was Bonnie, and she was the engineer on the Knight Rider team. She was the one man or one woman show dealing with engineering on this team. She was the electrical engineer and she was the computer scientist. And she helped the Knight Rider team to accomplish their goals with nice gadgets. And I really liked her. She inspired me to tell my parents that I need a computer. I told them, yeah, you know, it might be beneficial for school, which was not totally wrong, but it was also not totally the truth. But nevertheless, I got a computer, and so I started programming back then. So somehow she inspired my whole career. But when thinking back about Bonnie, one thing comes in mind that is very funny somehow. Namely, as mentioned before, she was a one-woman show. And this does not work nowadays, because nowadays we know that computer science and so also software engineering is a team sport. That means we need a lot of people to coordinate, and coordinating people is hard enough. But I tell you one thing, what's harder than coordinating people in one team is coordinating several teams. If you have several teams, then you need to establish more communication and you have to deal about more stuff. So this is very complicated if you ask me. But more and more companies see themselves in this position. And so the big question is how to deal with this. And the answer is quite simple. I think Luca has very nicely explained it before. The answer is not to write a big monolith like a flight system which can do anything like cooking coffee or booking flights or doing my invoices. No, instead of this big system, we are writing several tiny systems. The idea is quite old. It's almost about 20 years old. Perhaps it's even older, but about 20 years ago, it was described by domain-driven design. This idea was rediscovered several years ago when people began to write microservices. So in this case, they would write not a flight application, but a booking service and a check-in service and a luggage service and a boarding service. And with terms of domain-driven design, those services would be called the subdomains. A subdomain is something that exists out there in the real world, in your very business, and a subdomain should know as less as possible about the other subdomains. Because if they know as little as possible about the others, then they are really decoupled. And decoupling means you can change something here without affecting something there. I think we all know this very situation. It's an ugly situation. You fix a bug here or you add a tiny feature here, everything works, but there you break something. We don't like to have this very situation. When going with microservices, as Luca has mentioned before, you can assign one team to each of those services, so they don't need to coordinate much with other teams. And of course, as we had microservices, people started wondering how to put this idea into the front end. And this was when micro-frontends were born. Basically, micro-frontends go with the same idea. It is about subdividing a big front end into tiny, isolated parts, parts that don't know much about each other. So the big question is how to implement micro-frontends. And honestly, there is a huge amount of possibilities. But there was not this one and only solution, this turnkey solution. You had to deal with the DOM, you had to do DOM manipulations, some people dealt with iframes, some people used big web components, but this was not that funny. And so the good message is that Webpack 5 will bring a nice turnkey solution for building micro-frontends. It's called Module Federation. Basically, Module Federation allows you to load parts of another application into your application at runtime. That means your application does not know the other parts up front when compiling them. It only knows it when it is loaded at runtime. And this is exactly what we need for micro-frontends. So in this talk, I will show you two things. First of all, I want to show you how to use Module Federation. It is easier than you might imagine. And then I will give you a possible roadmap. There is not an official roadmap, but I will look into my crystal sphere and I will tell you what I'm seeing there. But first of all, let me introduce myself. I am Manfred. I'm a trainer and consultant for Angular. I'm doing a lot of Angular consultancy and workshops nowadays. In these times, I'm doing those workshops remotely, which really works well. For instance, the next workshop takes place next week. And besides this, I'm connected to the Angular community. I'm a Google developer expert for Angular, and I'm a trusted collaborator in the Angular team. Perhaps I might tell you a little story about the term collaborator, because the thing is, we in the German language also have the term collaborator. And it means exactly the same as in English, but always in a negative sense. Collaborating in German means teaming up with other people to destroy something. And well, if you look at my first pull requests, it was more of the German meaning of collaborator. Meanwhile, hopefully, I have reached the English meaning. Saying this, I'm doing a lot of stuff in the German-speaking area, and I'm always happy when I can work with companies that are based in other countries. Nowadays, it's very easy because now we do everything remotely. Okay, so much about me. So let's get started with Webpack 5 Module Federation. What is this about? And I'm always saying, well, Module Federation is like the 1980s. You cannot understand it if you have not experienced them. And so let's start with a demonstration. In this demonstration, I have a little application here. I'm calling it my shell because it is capable of loading other micro-frontends. For instance, when clicking here, I'm loading this red dashed micro-frontend. It's really a separate application. It can really run in standalone mode like here. That means you can develop it independently, you can test it independently, you can deploy it independently. And when it's deployed, this shell will load the newest version or a configured version into its working area. And when you look at this at runtime, it looks a bit like, let's say, lazy loading. So let's open the network tab here, let's increase the size, and let's click on flights. So as you see here, a chunk is loaded, a chunk with the very self-explaining name 798 ###. And as you see there, it is very tiny, 3.1 Ks. This is literally nothing. And this clearly shows that I'm not reloading Angular or any other library or framework. I'm just loading what I need to display this tiny micro-frontend, I just load the code for this micro-frontend. And this micro-frontend is sharing libraries with the shell. The shell is providing, let's say, Angular itself and other libraries like Bootstrap, for instance. The micro-frontend just picks it up. So perhaps you're saying now, yeah, Manfred, this is nothing new, because what you're doing there is lazy loading. No, it's more than lazy loading, because if you closely look at this location here, it is localhost 5000. And if you look there, it is localhost 3000. So that means this micro-frontend comes from a completely different origin. The shell application does not know it upfront. It only knows it when it loads it during runtime. And this is what module federation allows you to do. So in order to understand module federation, we have to answer this very question here. How is it possible to load separately compiled code at runtime? Perhaps you're saying now, well, that cannot be that difficult because, you know, we have this import statement, this dynamic import, which came with ECMAScript 2017. And even before we had require, AMD require and Node require. So it cannot be that difficult to use those mechanisms to point to another origin and to load something from there. But the thing is, when using Webpack, and so when using the Angular CLI, this does not work. Webpack does not allow for this by default, because Webpack assumes that everything is known at compile time. Webpack is compiling everything, and then it is doing some optimizations. And after that, it splits everything into bundles that can be lazy loaded. But before splitting, everything needs to be compiled and optimized together. And that's why things like this did not work in the past. Module federation, which will arrive with Webpack 5, will change this. And this will work too easy. It is really too easy to be true, because everything you need at first is a shell, which is also called the host with the general terms module federation is using. And you need another project, which I would call the micro-frontend. Module federation is using the more general term remote. And then the shell gets a mapping, a URL mapping. For instance, it maps the URL MFE1, which stands for Micro-frontend 1 in this case. Yes, I know I'm very creative. And here MFE1 is linked to MFE1. That means it is used to define an alias. Here it is a non-alias. I'm saying, hey, when I'm starting an URL with MFE1, I'm referring to something over there that's also called MFE1 over there. This does not have to be the case. Perhaps it is called MFE1 here and something different over there, like MANFRED, which is a very good idea. Please always call your micro-frontends MANFRED or Batman or something like this. Your colleagues will love you. Okay, here I'm just defining a URL. I'm not defining where this micro-frontend is located. This comes later in some seconds. Then within this micro-frontend, within this remote, I can expose parts of the frontend. I can say, hey, I want to expose this very file under the name CMB. Using this, I can expose components. In Angular, I could also expose ng modules with subroots. Literally, I can expose everything. And then I guarantee you something beautiful is happening. Then I can do an import within the shell. And this import is not pointing to something that exists within the shell, but to something that exists over there. Here I'm pointing to MFE1, and MFE1 is pointing to this micro-frontend, to this remote, which is published to another location. And over there, I'm grabbing what's called CMB, and I'm using it. It's really as easy as that. So perhaps you're wondering how to get the URL from the micro-frontend. And there are several possibilities for this. The easiest possibility to get the URL of the micro-frontend is to compile the micro-frontend in a way so that Webpack also spits out a remote entry point. A remote entry point is just a tiny JavaScript file, just several bytes. And then you load this tiny JavaScript file into the shell. And this tiny JavaScript file now tells the shell where to find MFE1. Of course, you can also do this dynamically. You can create a dynamic script tag, and meanwhile, you can also put the location of the remote entry point into the Webpack configuration of the shell. Also, as we will see in one of the next demonstrations, you can define everything dynamically. You can run some setup procedures when initializing the shell, and those setup procedures can tell the shell, well, I know under this location we can find this micro-frontend, and under that location we can find another micro-frontend. Saying this, there are lots of possibilities for defining the URL. There are more static possibilities and, of course, dynamic ones. Another question you might come up with is how to share libraries, because we don't want to load Angular 5 times if we have 5 micro-frontends. We don't want to load React 10 times if we have 10 micro-frontends. So how to deal with this? Well, actually, this is also quite easy with micro-frontends and especially with module federation. Everything you need in the configuration is a shared array. It does not need to be an array. It can also be a more advanced data structure, but the easiest way to get started is to use an array. And if you are pointing to a specific library here on the shell, if you are pointing to the same library within the micro-frontend, this library will be shared. That means the shell loads it, the micro-frontend does not load it. The micro-frontend checks at runtime, does the shell already have it? Does the shell share it with me? And if this is the case, it is just reusing Angular core from the shell. If this is not the case, the micro-frontend can fall back to load its own version of Angular core. That's why all those shared libraries are put in bundles of their own, so that they can be loaded on demand if the shell decides to not share them. And if you ask me, this is very nice, but conflicting shared libraries is also one of the biggest challenges in the area of micro-frontend. This does not only belong to module federation. This is a big challenge with each and every strategy you are going with. There are several ways to deal with it. One option could be to reuse the wrong version anyway, like the ostrich, you know, this big bird who is putting his head into the sand until the danger is over. This happens here. You reuse the library anyway, even though the shell shares the wrong version. Let's be tough. Another option would be to load your own version. So the shell is sharing Angular 9, you need Angular 10, and so you need to load your own Angular version, which is 10 in this case. And honestly, both might be bad. Both is nice, but both might be bad. If it comes to a tiny library like RxJS or to some HTTP client, this might be okay-ish. But when it comes to your leading framework, to your leading library, none of those options is perfect. Both options will cause some damage, I suppose. And so you might to prevent these situations with conventions, with contracts, or even with a mono repository. Yes, mono repos and micro-frontends fit together. Micro-frontends by the book are always done with several repositories, but there is really a sweet spot if you try to combine those ideas of having mono repos and separately compilable and deployable micro-frontends. But this is a whole different story, and I will not tell the story today. Of course, integration testing can help to make sure that everything that meets at runtime can work seamlessly together. And another idea seems to be very clever. Before deploying your micro-frontend, you could compare your versions, the versions of your micro-frontend and the shared version of the currently deployed other parts, of the currently deployed shell, of the currently deployed other micro-frontends. So you can check if it is safe to deploy this very version of your micro-frontend. Okay, let me show you a demonstration for this. In this demonstration, I will dig a bit into the source code of this application. And for this, let's start Studio Code. And here, let's open my routing configuration, app.routes.ds from my shell. So as you see here, everything my shell is doing is lazy loading. It is doing lazy loading using this route with load children and using a dynamic import, an ECMAScript 2017 based dynamic import. Angular does not know at all that this URL is mapped to another remote, to another micro-frontend. So from Angular's perspective, from the shell's perspective, everything is like all the time. We have just traditional Angular here, loading another module on demand. But underneath the covers, Webpack makes sure that every time this URL is requested, we are fetching something from over there, from this separately deployed micro-frontend. And to make this happen, we need a Webpack configuration. Here we see the Webpack configuration of the shell. It's a typical Webpack configuration. Everything we need to add is this here, the module federation plugin. It is telling the shell, well, I'm mapping the path MFE1 to something that's also called MFE1 over there. In the newest version of module federation, you can also define here the path. I'm doing this at runtime. And then I'm saying, hey, I'm sharing those libraries with the micro-frontend. It does not bring its own, I'm sharing it. This needs to be done for the shell. When it comes to the micro-frontend, I'm also using the module federation plugin. It's the same plugin. I'm assigning a name to this micro-frontend, MFE1. I'm defining the name of the remote entry point, and I'm exposing stuff for the shell. 𝗬𝗬𝗬𝗬 app component and 𝗬𝗬𝗬𝗬 flights module is what I'm exposing, and I'm exposing it under those pretty names. I'm also saying, hey, I want to share stuff with the shell. So if the shell is offering those libraries, I'm just grabbing them. I'm not loading my own. Of course, this is very natural if you are using React or if you're using Vue. For Angular developers, using Webpack configurations is not usual anymore. It was usual back then, I think 4 years ago. But meanwhile, we have the Angular CLI, which is creating this Webpack configuration for us. And so in the end, we have to find a way to tell the Angular CLI to do what it is doing all the time. And in addition to it, it needs to squeeze this configuration into its very own Webpack configuration. For this, I have some ideas. I will talk about it in some minutes. Okay, so everything we are doing is to use this module federation plugin to point to a remote or to define a remote exposing things. And now everything we need to do within the shell is, I think it was the wrong index HTML. Let's take the right one. Everything we need to do within the shell is to reference this remote entry point. This can be done statically like here, by introducing a static script tag. Of course, we can create a dynamic script tag, and there is a thing called dynamic module federation, where I'm using in some seconds. Okay, and this is everything you need to get started with this kind of module federation. Saying this, there is another flavor of module federation. I'm calling it dynamic module federation. In the classical flavor, which is very nice to get started with module federation, you define the remotes directly within the shell's configuration. When you go with dynamic module federation, you don't do this. In this case, you don't know your remotes, your micro-frontends upfront. Perhaps you are calling some service when the application is starting, and the service tells you, well, today we have this micro-frontend over there and this micro-frontend here. Instead of mapping your micro-frontends upfront, you are just using a helper function. I'm calling this helper function load remote module. Saying this is a handwritten helper function. It is dealing with the Webpack runtime API. This Webpack runtime API is not that pretty, if you ask me. It's a low-level API, and so you will very likely end up with wrapping it into something that can be used nicely, like this load remote module helper function. But if you look at the arguments of load remote module, you see what we have defined before in a static manner. You see it is pointing to a remote entry point. It is pointing to the name which has been assigned over there, and it is pointing to the exposed file. But now it is dynamic. That means you can get all this data at runtime from a lookup service, for instance. And for this, I have another demonstration for you. So let me switch windows. The blue screen is the screen with the second demonstration. Very important, so that I'm not getting confused. Everything is starting. So let's reload this. And here we go. So what I'm having here does nothing have to do with micro-frontends. This is just a plugin-based workflow designer. That means I can add some workflow tasks to this page. And the best of this is the workflow designer does not know those tasks upfront. It is informed about those tasks by a configuration service. When starting up the application, this configuration service informs my plugin-based workflow designer where to find which action. For instance, this download action here can be found under this location within this micro-frontend, and it is exposed under this name. The upload action can be also found within the same micro-frontend at the same location, but it's called upload. The analyze action can be found on another location. Here you see it is 3001 and not 3000 within another micro-frontend, and one more time, it is exposed under another name. So everything I need to do here is to take this lookup data and put it into this helper function I have shown you before, and well, then I'm getting the component from over there. Nice, isn't it? Of course, as mentioned, this does not have to do much with micro-frontends, but it is the same mechanism, and it clearly shows that you can load everything, workflow tasks or full micro-frontends at runtime without the need to know them upfront. Okay, cool. So perhaps you're saying now, well, I like this. When can I have this? And now I have to say, well, please be patient, because we are talking about something that is beta currently. It is in beta. So the thing is, Webpack 5 is currently in beta. And there is not an official release date I know of, but rumor says it will be released in late summer, perhaps in early fall. And if this is the case, it comes early enough to be incorporated into the next version of the CLI. You cannot really use it nowadays with Angular, because to make it work with Angular, I needed to patch the Angular CLI. That means in my examples here, I'm using a patched version of the Angular CLI. Obviously, this is not a good idea for production-ready software, so don't try it at home. And also, we need to deal with this custom Webpack configuration. And Angular developers don't do things like this nowadays because we have the Angular CLI. And the CLI cannot incorporate it before version 11, which is due in fall 2020. In the last years, it was late November, I guess. So there is a chance, a very good chance, that Webpack 5 comes early enough to be incorporated into version 11, and then everything is fine. Well, everything we need then is to find a way to squeeze this tiny module federation config into Angular's big, huge Webpack configuration. And for this, there are solutions available already today. For this, you can go with custom builders. Custom builder is just extending the CLI. It is teaching the CLI new tricks for building. And one of those is a builder I have written. It's called ngxBuild Plus. ngxBuild Plus allows you, for instance, to merge a tiny partial Webpack configuration. It could be a Webpack configuration with a module federation config into the big Webpack configuration of Angular. Yeah, and then you are on the safe side and you can use this cool stuff here. Well, saying this, if you really like this topic, I have this free ebook. You can check it out under my website, 𝗟𝗨𝗖𝗔𝗟𝗏/book. You can just download it there. You find a lot of material about micro-frontends in there, also material about alternatives to module federation. And it also tells you a lot about domain-driven design, which is the methodological basis of micro-frontends, as Luca told you in the last session. So if you like this topic, check it out. If you liked this talk, also check it out. And if you did not like this talk, check it out anyway. Perhaps I'm writing better than I'm speaking. Who knows? Okay, let me come to a conclusion. What did we see today? Well, we have seen the main purpose of using micro-frontends is scaling teams. Please never ever forget this. It is not about fancy technology. It is not about mixing and matching different front ends. Yeah, that's possible, but the main purpose is scaling teams. And you know, a good friend of mine told me teams is plural, which means you need to have more than one to reach this goal. If you have just one team, then this does not make sense. And it is also about decoupling. You want to have loosely coupled parts of your overall software system. The less they know about each other, the better it is. Because if they don't know much about each other, you can change one part within influencing another part. Module federation allows you to import from another application, from an application that has been developed by another team, deployed independently over there. It also allows you to share libraries. And you somehow have to take care of conflicts. Perhaps one of the strategies of module federation fits, or you have to introduce your own tooling or your own conventions. Also, as mentioned before, using a micro-frontend, a mono repository can help here, because it forces you into using just one version of all the libraries, or at least it can force you into this. And there is a last thing I want you to remember all the time. If you forget everything, please remember this one thing all the time. Please try to be a big like bunny, because Bonnie was always thinking first. In opposite to her counterpart, to the other star of this TV show, he was always hitting first, and then perhaps he was thinking. But Bonnie was always thinking first. She was the engineer on the team. And what do I mean with this? Well, I mean with this, first of all, evaluate whether you need micro-frontends. If you have several teams, if you need to scale, then micro-frontends might be a good solution. If you don't have several teams, don't go with all the overhead of micro-frontends. It is complicated. You have to deal with versions. In this case, go with a majestic monolith. I like this term, the majestic monolith. You know, the microservice people are always claiming that a monolith is something that's bad. You are a bad guy, a bad person if you are building a monolith. And some other people coined the term majestic monolith for this reason. They said, no, a monolith does not need to be something that's ugly, something that's dirty. If you take care about it, if you have a proper architecture, if you take care that this architecture is met, then it can be something beautiful, something majestic. If you have several teams, if you need to scale as mentioned, please consider module federation. It is a very attractive solution for building micro-frontends nowadays. Okay, here you have my contact data. You also find all my material on my blog. And if you like, follow me on Twitter so that we can keep contact. So thanks for having me. And I think now we have a Q&A session.
Thank you a lot, Manfred. Very nicely said. Very nice presentation. A couple of questions appeared here. So we will try to answer them and go through all of them. So the first one from Chris. Do you still have one build with one Webpack config that needs to be redeployed when micro-frontends are updated?
I'm not sure if I got this. Can you repeat it?
Do you still have one build with one Webpack config that needs to be redeployed when micro-frontends are updated?
No. You can update the micro-frontends in isolation. They don't need to be within the same repository. You can even put them into separate repository. That is what is normally done when you are doing what I'm calling micro-frontends by the book. And in this case, just update it and redeploy it. And somehow you have to make sure that everything works when it is meeting each other at runtime.
Yeah, that's what I thought. That basically that's the point, that you do not have to do this and redeploy every time that one of the micro-frontends changes. Next question here is very interesting from my point of view. Hi, Manfred. Can we make library sharing in more complex configuration? For example, shell is loading micro-frontend 1, which is loading micro-frontend 2, and probably etc. etc. So is this somehow possible or how to do this?
Yeah, that works totally. So for the sake of simplicity, I had those two roles in my presentation. I had the shell, which was also called the host, and I had the micro-frontend, which was called the remote. But the whole truth is that one application can be both at the same time. It can be a host and a remote at the same time. So this is totally possible.
Great, answered. And the next two questions, I will couple them because they seem really similar. The one of them is, do you need to keep share libraries at the same version? This is the first one. And the second one is, with Webpack Federation, can different micro-frontends load different, in brackets, breaking versions of Angular and deliver the needed version of Angular? So somehow solve the conflict of the versions here?
Yeah, so this is a very nice question because it clearly shows one thing. When it comes to micro-frontends, it is about trade-offs. And there are two things you cannot accomplish at the same time. One thing is the full isolation. which means one micro front end can come with Angular 5 and the other one with Angular 7 and the next one with Angular 10, and lightweight bundles. You cannot have both of them. Of course, you can find ways to bundle your Angular version into your application bundle. And in this case, you cannot reuse Angular. And this can be made working, but you have to take care about specific things. The easiest way to use module federation is just to have one version of Angular, because in this case, you can also use Angular and the Angular router for the shell. But I have also seen applications where each and every bundle had its own version of Angular, and this is easier than you think to accomplish, because in this case you have a shell which is pure ECMAScript, and this shell is just loading this Angular application at runtime with a dynamic script tag, and then it is loading that Angular version at runtime. And when compiling with Webpack, everything, also the libraries, are hidden behind a closure. So Angular here does not see Angular there, and everything the shell needs to do, and I think this is also what Luca is doing, is to show and hide the dynamically loaded single page applications. And of course, this could also work with module federation, but you don't need module federation for this very specific implementation.
Yeah, thank you for answers. Completely makes sense. I will mark both and answered. And the last question is that when you configure routes dynamically, does this mean that first load of page is calling all micro-frontends to get all routes?
It does not mean that, no. So with module federation, we are doing lazy loading. It's more than traditional lazy loading, because it's lazy loading of things we don't know during the compilation time. Everything we need to load upfront in the very simple scenario I've shown you at first is to load the remote entry point, which is just a tiny file with several bytes telling the shell about where to find the micro frontends when we need them. When we go with dynamic module federation, we don't even have to load the remote entry points upfront. In this case, we know the location of the remote entry point and we load it on demand.
Yeah, so pretty much lazy loaded in the normal terminology. Yep, great, answers the question. So that's all from our audience. Thank you, Manfred. Thank you for your presentation. It was really great. It inspired me to do some more research about the topic and about the Angular itself, because it's going into really interesting direction. We will all keep our eyes on the evolution of the Webpack 5 beta version, whether it will be out or till the end of the summer or some around the time. So fingers crossed. Thank you once again also for the Q&As and your answers. Maybe there will be some more questions on Slack later during the day. So if you can answer that as well, if something appears, it would be much appreciated. And thanks once again. Enjoy the rest of the evening. Thank you.
Bye.
For the rest of you and the rest of our audience, thank you for staying with us and Luca and Manfred this evening. It was great. I hope you all enjoyed it as I did. So if you have any more questions, just join the Slack and ask there, or keep discussion there. I think that this is the really hot topic right now, with a lot of opinions going on, a lot of people having some experience with it. So let's go through this highly dynamic phase of implementing or starting with the implementation of micro frontends and share the experiences, so we do not all make the same mistakes. And that's it. And after end of this webinar. There will be a feedback form on Slack, so feel free to give us the feedback, maybe some topics which you want to hear more about. So everything you have to tell us will be much appreciated, that we will try to do our best to implement it in our next meetups. So thank you for joining us. Talk to you on Slack and see you sometimes in the future. Stay tuned on our social networks. We will keep you informed. Enjoy the rest of the evening, and goodbye, everyone.